Hello everyone. In this video, we are going to look at metric prefixes and conversions. And really it's this section of your notes, 11 down to number 15. But before we can take your notes, we also need to have handy our metric prefix chart. And we're going to start by completing this chart together. So I have my chart handy here. Let me kind of adjust the spacing so you can see it better. And I need to open up a file, so give me a second, and here we go. Okay, so we are going to start here at the number 1. So let's pretend I had 1 of something. So I could have 1, I'll put under symbol, I could have 1, getting like 1 gram. 1 gram. I could have 1 meter. I could have 1 second, but I have 1 of something. So there's no prefix when you have 1 of something. But what if I had 10 of something? Then we use the prefix deca. So D-E-K-A, deca. And like if I had 10 grams, it would end up being written as decagram or deca seconds, etc., etc. If I had 100 of something, it's hecto. So if I had 100 meters, we could say that we have hectometers, just as an example. And if I had 1,000 of something, then we could say kilo. So if I have 1,000 grams, then I would have a kilogram. All right, so we're going to store those. We can also have a fraction of something. So I could have just like 1/10 of something, and that is deci. So if I took a meter stick and took 1/10 of the meter stick, I would have decimeters. Notice that because we have a D here and we have a D here, sometimes people throw a K in here, DKG, or sometimes people capitalize this D to differentiate between them. So I don't know if there's a right way or a wrong way, but I've seen it done both ways. So we just have to kind of go with that flow, but we do have to differentiate. All right, what if I had 1/100th? So I take the meter stick and I divide it into 100 little pieces, and then the little piece would be called a centi. So if I had 1/100th, I would have a centimeter. It's 1/100th of a meter stick. 1/1000th is a milli, and that would be like 1/1000th, let's say, of a liter would be a milliliter. So milliliter would be M with a cursive L, but sometimes when you type it, it just looks like an L like that, which looks like a 1, and that can confuse people. So sometimes we use a capital L to stand for liter, just so we can see that it truly is a liter and not a 1. All right, but you probably learned these units in chemistry. And so most people know the units up to 1,000, up to kilo, and down to 1/1000th. But today we're going to expand and go way up and go way down, because there's more metric prefixes that we need to look at in physics. So we're going to be talking about very, very large things like the distance from our solar system to another galaxy. And we're going to be talking about very, very small things, distances inside the nucleus of an atom, etc., etc. So we're going to learn some more prefixes today. All right. So now we have a new pattern. So we left off at 1,000, which is 10 to the 3rd power. When we get to 10,000, which is 10 to the 4th power, there is no prefix. So I'm just going to put little dashes there. 10 to the 5th power, 100,000, no prefix. But when we get to 1,000,000, 10 to the 6th, there is a prefix. and that is mega. Once we get above kilo, all of these prefixes are very large, and therefore they're capital letters. So if I had 1,000,000 seconds, we would call that a mega second. All right, there is no prefix for 10 to the 7th or for 10 to the 8th, but there is a prefix for 10 to the 9th, and that is called giga or giga. So like how you pronounce it depends on what you're talking about. If we were talking about your phone, like the size of the memory of your phone, you might call them gigabytes. If we were talking about the unit of power, which is a watt, we would pronounce that as gigawatts. So sometimes it has a hard G sound and sometimes it has a J sound. But we're going to continue this pattern all the way up, where there's only going to be a metric prefix for the powers of 3. So there's going to be no 10, no 11, but there is a 12. 12 starts with T. That helps me remember it. So it's Tera. That's capital T. There's no 13 and there's no 14, but there is a 15. And 15 reminds me of a pentagon, and so it is peta with a P, capital P. And there's no 18, 16, and no 17, but there is an 18. 18 starts with E, and that is exa. That's going to be a capital E. So if I had 10 to the 18th meters, I'd have an exameter. All right, the last two, there's no 19, there's no 20, but there is a 21 and there is a 24. So the last two letters of the alphabet are X, Y, Z, Y, Z. They're backwards. This one is Z and this one is Y. That's how I remember them. This one is called zeta. Zeta. If you have 10 to the 21 of something, you have zettagrams or zettaseconds. If you have 10 to the 24, you have a lot of them. And so that one is yada, like a yada them, a lot of them. All right, so we have lots more prefixes that go all the way up to 10 to the 24. And then we also have some fractional prefixes on the bottom. So we're going to do the same thing down here. And it's the same pattern where we only have prefixes for the third powers, the negative third powers. So there'll be 6, 9, 12, 15, etc., etc. So there is no -4 or -5, but there is a -6. And the -6 is called a micro. So I'm going to write down micro. But like what symbol should we use for micro? We used little lowercase m for milli. We used capital M for mega. And like we're out of M's. So oftentimes when you're out of a letter, we go to the Greek alphabet and we use the Greek letter M, which is pronounced mu. And when you write a mu, it looks kind of like a U with a front tail on it. So if I had a fraction of a second, 1/1,000,000th of a second, we would call that a microsecond and put that on there. All right, there is no 7, there is no 8, but 9. There is a 9 and that a -9, and that is nano. So if we had 1 times 10 to the -9th seconds, we could say that a nanosecond has gone by. So we'll use the N for that. There is no 10 and there is no 11, but there is a 12, and the 12 is pico. Pico. We could have picometers, picoliters, picobytes, picowatts, and that's going to be a P. These are all lowercase letters, by the way. -15. This one is femto. Starts with an F, femto, and that's capital F. No 16, no 17, but there is an 18, and 18 is atto, A-T-T-O, and we'll put an A there. No 19, no 20, but there is a 21, and 21 And there is a 24, same thing. The Y and the Z are flipped. So this one becomes the Z, this one becomes a Y. That helps me remember them. This one is Zepto, Zepto. And this one is Yakto, Yakto. Okay, so we don't have to memorize these. We just have to know how to use the chart. So let's go back now to our notes now that we have our chart filled out. All right, so the metric prefixes go from 10 to the negative 24 all the way up to 10 to the positive 24. And that's all of them. So you're not going to ever learn new ones. We have them all in our chart now. And what is the metric prefix for 10 to the negative 6? We can look that up in our chart and we find out it's a micro. And what is the symbol for micro? Again, a U with a front tail. What is the metric prefix for 10 to the positive 6? That's a mega. And things above kilo have to have a capital letter. All right, what does GB stand for? Gigabytes. Where do we use gigabytes in real life? Again, memory in your phone, your computer, etc. What does GW stand for? And that would be a gigawatt. But notice this was giga, this was giga. Okay. All right, so we should be able to use our metric conversion chart to convert to the specified unit. So we are going to pretend that we have 500 kilometers. So let's just say we traveled 500 kilometers, and I would like to know how many centimeters that is. So kilometers is a kilo. So I'm on the kilo step, and I am going to centi. So I'm going down. And so it says when moving down the chart, move the decimal point to the right. So I'm on kilo, so I put my finger on kilo, and I'm going to count how many steps it takes for me to get to centi. So I'm on this step, so then it takes 1, 2, 3, 4, 5 steps for me to get there. So I'm going to move my decimal point 5 places to the right. So my decimal point right now is right here, but I'll move it 5, 1, 2, 3, 4, 5, and then I'll fill in with zeros. I'll put little commas in here so we can see it better. And that's going to be 50 million centimeters. You obviously could write that number in scientific notation if you wanted to. All right, let's do another one. So we have gigawatts, and we want to know how many microwatts that is. Well, micro, those are like tiny things. So there's going to be tons of them. All right, 1.21 gigawatts. If you recognize that number, it comes from the Back to the Future movie. All right, 1.21 gigawatts. So let's find giga. That's up here. I'll put my pen dot there. And I now have to count how many steps to go to micro. How many steps to go to micro? Micro's down here. So just because there's no name for a step, no prefix for a step, we still have to count that step. I still have to make that. So I'm starting at giga and I'm counting how many steps to micro. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 steps. And again, I'm going down. So I'm going to move my decimal point 15 places. So here goes. I'm going to move it 1 spot, 2 spots, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Comma, 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 comma. And again, you could write it in scientific notation if that was easier for you. All right, let's do one where we're climbing up, that we're going up. All right, so this time we have a lot of nanoseconds. We want to convert to hectoseconds. So we are on the nano step, and we have to go up to the hecto step. So I'm going to put my pen there, and I'm going to count the steps to get there. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11 steps to get there. Since I'm going up the chart, I'm going to move my decimal point to the left 11 places. So my decimal point right now is here. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, put the decimal point, and then fill in with zeros. So that's going to be 0.00234, and I don't have to write all those extra zeros after that. Okay, so I want you to know how to use the metric prefix chart. You probably have used one in the past, maybe one not as large as this one, but know how to count up or count down to do metric conversions. The other piece of this lesson is this here. This video is a classic video. It's called The Powers of 10, and it was made, I think, like in the 1970s, but it's like you see it all the time. You'll see it in high school. You'll see it in college. You'll see it in commercials. But this video gives you a visual of how big and how small these prefixes are. Like, for example, like 10 to the 18. How big is that? Do we really know something that's that big? What about 10 to the negative 18? Do we really know something that is that small? So I have posted the video in Schoology. You can also just Google it on YouTube. But I want you to watch the Powers of 10 video with your chart in front of you. And I want you to tell me how high up it goes, how far down it goes, and then record some things in here. The last thing before we close out, we won't make a career out of this, but I want to show you that even the way different countries talk about numbers is different. Like, we would think that like a billion meant the same thing for all countries. But we notice that some countries use something that's called the short scale. And a billion happens to be equal to 10 to the 9th. So if you order a billion bolts, you're going to get 10 to the 9th number of bolts. But other countries say a billion is 10 to the 12th. They use something called the long scale. So this is just some general concepts of who uses what scale, but it would be important to know that if you were involved in international trade or working with different countries, that even the way we describe our numbers is different. Another reason that we should standardize these words also. All right, that's all we need to talk about in this video. So we'll close there. Make sure you watch the Powers of 10 video that's posted in Schoology.